Alrighty, let's take a look at this question. So, use linear approximation to approximate the square root of 64.2 as follows, but they lead us into it. First of all, since we're trying to approximate the square root of something, we're going to use the function f of x equals square root of x, right? And then the idea is that we're going to get the equation of a tangent line to the curve at a point very close to the one we're looking at, except one we actually know the square root of so that we can get the coordinates. So that's what we're going to do first. So first we need the slope, and then to get the slope we're going to do the derivative. So f prime of x equals, and that's like x to the 1/2, so we use power rule, 1/2 comes down, x to the negative 1/2. And that is the slope of the tangent line at any point, but we want the slope of the tangent line at 64. So f prime at 64, and I'm just going to rewrite that a bit. So it'd be 1 over, want positive exponents, and the 2 can go to the bottom as well because it's the fraction 1/2. And that'd be x to the positive 1/2, which would then be written as square root. So we have square root of 64. All right, now let's get that number. Square root of 64 is 8 times 2 is 16, so the slope would be 1 over 16. All right, and then the equation of the tangent line. So do we have a point? Let's see, x is 64, and then y would be, since it's f of x equals square root of x, we'd put 64 into that equation. So square root of 64, our y value would be 8. Okay, so we have a point, so let's use slope point form to get the equation of the tangent line. Oops, didn't mean to write a positive sign there. Okay, and then minus x1. All right, sub that point in. So y minus 8 equals, the slope was 1 over 16, and x minus the x coordinate was 64. Simplify that a bit by multiplying the 1 over 16 through, and that would turn into minus 4 when you go 1/16 times 64, and then we would add 8. So we'd have 1/16 x plus 8, or sorry, plus 4 would equal y. All right, so that is our mx plus b. So our m would equal 1 over 16, and our b would be 4. So the tangent line crosses the y-axis at 4, kind of like what I drew down here. So we've got, this is our tangent line in green, and it's crossing here at 4. And the slope of that is very shallow. It's 1 over 16. Okay, so the idea of approximating this is we're going to use that green line to go to a point at 64.2, and we'd be estimating the y value there. Now, yes, it would be slightly different. Let me zoom in. This part here, from here to here, would be the error between what we're going to estimate and then what it actually is on the red curve. But that's okay. It's an approximation. It's going to be a pretty good answer. Okay, so now we're on to the next part, which is finding the approximation. So we're going to use the equation of the tangent line. So y equals 1 over 16x plus 4. And we're going to use an x value of 64.2 so that we get an approximate value for the y. And you could just put that in the calculator. Actually, I'm going to have to put it in the calculator. So if we go 64.2 divided by 16 and then plus 4, you get 8.0125 would be the approximation for the square root of 64.2. And of course, you can always confirm that on the calculator by doing the square root of 64.2, and you get, on the calculator, 8.012490. So very close actually. So that's what you would put, is not what you did on your calculator, but what you did with the linear approximation using the tangent line. So 8.0125 would be the approximation for y, or the value of the square root of 64.2. And there we go. I hope that helped.